Every single second, 9,722 Reese's peanut butter cups are manufactured. That's 840 million cups daily, enough to fill 47 Olympic swimming pools with pure chocolate and peanut butter perfection. But here's the extraordinary part. This global confectionery empire began when a desperate dairy farmer invested his last $1,000 in 1928. Today, that same recipe generates $3 billion annually, making it Hershey's most profitable product and America's top-selling candy brand. What transforms this simple treat into a $3 billion addiction? The answer lies in facilities where 2.5 million pounds of peanuts undergo molecular gastronomy-level engineering daily. Every element, from roasting temperatures to assembly timing, is calibrated to trigger maximum craving response in your brain's pleasure centers. Welcome to Process Nest. You're about to witness manufacturing processes that will fundamentally change how you perceive that seemingly simple treat you can't stop eating. The engineering behind your addiction is nothing short of extraordinary. In the shadow of the Appalachian Mountains, Hershey's sprawling 2.2 million square foot facility operates as the epicenter of American candy manufacturing. This technological marvel processes 100,000 tons of raw materials annually, employing 15,000 specialized technicians who maintain production standards exceeding medical device protocols. When H.B. Reese first developed his cups in a converted garage, his original hand-formed cups required 45 minutes each. Today's automated systems achieve the same result in 3.2 seconds per cup. They maintain flavor profiles so consistent that chemical analysis shows less than 0.05% variation between batches. The production floor spans 7 interconnected buildings, each dedicated to specific manufacturing phases. Steam tunnels connecting these structures maintain optimal product temperatures during transfer, ensuring no thermal shock affects ingredient integrity. With this precision foundation established, the transformation begins with the most critical ingredient, the peanuts themselves. The journey begins with runner peanuts sourced exclusively from Virginia, North Carolina, and Georgia, regions where soil composition produces nuts with optimal oil content of 49 to 52%. Pneumatic systems transport 50,000 pounds of peanuts hourly through sealed networks, preventing oxidation. The cleaning phase employs sophisticated destining processes using density separation technology. Peanuts pass through oscillating screens, while air currents remove debris particles weighing less than 0.02 grams. The roasting phase represents where Reese's achieves its distinctive flavor through what quality control manager Sarah Chen calls engineering serendipity. The moment you walk into the roasting facility, the rich, nutty aroma hits you like a wave. Imagine the most perfect peanut butter cookie multiplied by 1,000. That serendipitous malfunction created Reese's trademark granular texture that triggers something primal in your brain's pleasure centers. Now buckets on the conveyor transport cleaned peanuts into this giant tunnel roaster where they travel through dry heat for exactly 35 minutes at 289 degrees Fahrenheit. But here's what makes it special. Reese's purposely over-roast their peanuts just enough to bring out that bold, addictive flavor. The extra heat creates their signature granular texture that fans can't get enough of. Once perfectly roasted to Reese's exacting specifications, these premium peanuts face their ultimate transformation into America's favorite candy foundation. Once perfectly roasted, the nuts travel along the conveyor belt that eventually drops them into this industrial-sized grinder. As the peanuts cascade into the machine, 2 massive steel plates spin just millimeters apart, crushing the nuts into rich, warm butter that fills the air with an aroma so intense it makes your mouth water instantly. The butter is then pumped through a maze of pipes and into the mixing zone. That's where salt, sugar, and a touch of hydrogenated oil gets added in. The oil keeps everything stable so you don't end up with a pool of separated peanut oil in your finished cups. Lead processing technician Marcus Rodriguez, with 23 years of experience, monitors the consistency with expert precision. The butter has to flow like liquid gold, Rodriguez explains, testing samples with practiced hands. Too thick and it won't fill properly, too thin and it loses that signature texture people crave. Once everything is blended, the mix is churned until it's smooth, spreadable, and ready for the next transformation. Part of this butter gets sent to bottling for the spreadable jars you can buy in stores. When it's time to prep the peanut butter for actual cup production, these barrels get wheeled under a giant vacuum-style machine. The device efficiently draws up the peanut butter and sends it through large tubes straight into nearby mixers, where the final candy-specific formula gets perfected. While this peanut butter operation reaches industrial perfection, parallel chocolate production unfolds with equal sophistication and precision. Simultaneously, chocolate production operates in parallel processing chambers, rivaling pharmaceutical manufacturing in precision. But here's the secret most people never realize. Reese's chocolate formula differs significantly from standard Hershey bars, incorporating specific modifications that create an almost drug-like compatibility with peanut butter that hijacks your brain's reward system. The process begins with cocoa beans sourced from Ecuador and Ghana, regions producing beans with theobromine content exceeding 1.2%, the natural compound creating chocolate's addictive euphoric effect. Roasting occurs in specialized drum roasters, tumbling 1,000 pounds of beans simultaneously while maintaining internal temperatures of 250 degrees Fahrenheit. Winnowing systems separate cocoa nibs from shells using density-based air classification. The nibs enter grinding mills, reducing them to chocolate liquor with particle sizes smaller than 25 microns, finer than human hair width, eliminating any detectable grittiness. The chocolate liquor combines with meticulously measured sugar, cocoa butter, milk powder, and vanilla in conching machines. These machines knead the mixture for 72 hours continuously. This extended period develops smooth texture while eliminating residual moisture and volatile compounds affecting shelf stability. Tempering represents the most technically challenging phase. It requires chocolate to be heated to 115 degrees Fahrenheit, cooled to 84 degrees Fahrenheit, then reheated to 88 degrees Fahrenheit in carefully controlled sequences. This thermal cycling creates proper crystalline structure. It produces chocolate's signature snap and glossy appearance. With both core ingredients perfected through parallel precision engineering, the intricate choreography of assembly begins. The assembly floor operates like a high-speed orchestra where three critical components unite to create perfection. Paper cup liners drop into circular molds on the production line, positioned with mechanical accuracy that ensures each one sits perfectly aligned for the magic about to unfold. First comes the foundation. Liquid chocolate flows from overhead dispensing towers, with precision nozzles delivering exact amounts into each waiting liner. The chocolate spreads across the bottom and climbs the sides, forming the structural shell that will cradle the star ingredient. From above, the peanut butter filling descends through gravity-fed systems into specialized extruder equipment. Inside these machines, the creamy mixture gets pushed through circular openings while rotating blades slice off perfectly portioned rounds. Watch these golden portions drop with surgical accuracy into the center of each chocolate-lined cup, landing exactly where they need to create that perfect bite ratio. The capping process completes each cup's construction through additional chocolate deposition that seals the peanut butter core like edible perfection under glass. Overhead, dispensing systems apply exactly 2.8 grams of chocolate to each cup's surface, and here's where the magic becomes visible. Watch as chocolate flows across the peanut butter filling, creating that perfect seal, keeping every ounce of creamy goodness locked inside until you bite down. Air knife systems immediately follow, using filtered air streams to eliminate surface imperfections and create the mirror-like finish that makes your mouth water before you even unwrap it. The air pressure requires precise calibration. Insufficient pressure leaves imperfections, while excessive pressure creates surface dimples, ruining that Instagram-worthy glossy sheen. Assembly Supervisor Janet Morrison oversees this intricate coordination with expert precision. Timing is everything, Morrison explains. Each element must arrive at exactly the right moment, or the entire sequence fails. We're orchestrating 2,400 individual assemblies every minute with visual perfection as our standard. Cooling tunnels extend 45 feet in length, maintaining internal temperatures of 55 degrees Fahrenheit for exactly 18 minutes. This controlled cooling allows chocolate to achieve proper crystalline structure while preventing thermal shock that could cause surface blooming or internal cracking. Each cup emerges with that signature snap and glossy appearance that defines premium chocolate. Quality control technician David Park monitors this entire process through advanced machine vision systems with obsessive attention to detail. Every cup must be visually perfect because we know the first bite happens with your eyes, Park explains. When someone sees that flawless chocolate surface, their brain is already releasing anticipatory pleasure chemicals before they even taste it. Weight verification systems confirm each cup contains 17.0 plus or minus 0.5 grams of material. Cups failing specifications get automatically diverted to recycling systems where they're melted down and reprocessed, ensuring zero waste throughout the operation. The packaging phase employs high-speed wrapping machines applying orange foil wrappers at rates exceeding 800 cups per minute. The wrapping process requires precise tension control to prevent tearing while ensuring adequate sealing around each cup's perimeter. With individual cups perfected and packaged, they transition into distribution networks designed to deliver global satisfaction. With individual cups perfected and packaged, they enter global distribution networks spanning 6 continents. Automated systems organize products into retail configurations, while climate-controlled warehouses preserve quality during storage. The scale is remarkable, millions of packages moving simultaneously through global supply chains. From Pennsylvania facilities to worldwide locations, every Reese's cup maintains identical taste and texture that consumers expect. From H.B. Reese's garage workshop to today's manufacturing complex, this process transforms simple ingredients into billions of cups annually, creating the world's most popular peanut butter chocolate combination through precision engineering excellence. The next time you take a bite of a Reese's cup, remember, you are tasting a $3 billion accident engineered to perfection. At Process Nest, we turn everyday products into extraordinary stories of precision, chemistry, and design. Subscribe to uncover how your world is really made. One machine, one molecule, and one moment at a time. What everyday item should we deconstruct next? Drop your ideas in the comments. The most liked one becomes our next episode.